In this video, we'll take up the homework sheet on geometric sequences. So for the first question, it asks me to find the common ratio for each geometric sequence. So you can take any pair of any successive terms and find the common ratio. So for example, like the first sequence, you can say 12 divided by 3, and you'll know that the common ratio is 4. For the second question, they gave us so in 2a they gave us the first two terms, and for 2c they gave us the explicit formula. Either way, you just need the first term and the common ratio, and you can build the value of the first 5 terms. So just 2 times -3 times -3 times -3, and so forth and so on. So 2 is pretty straightforward. For question 3, they're asking us how many terms are there for each of these sequences. So use the formula for the general term of a geometric sequence, and then you can use logarithms or set them as 2 powers with the same base. So for like 3a, I have 2 powers of the base of 7, and since the bases are the same, I can equate the exponents. Now for 3c you can't do that though. For 3c you can't use logarithms because the base is negative. So for 3a, b, and d you could use logarithms if you wanted. Okay, for question 4, they're asking me if it's geometric, arithmetic, or neither. So if there's a common difference, it's arithmetic. If there's a common ratio, it's geometric. If there's neither a common difference nor a common ratio, it's neither. For question 5, it's very similar to question 3. Yeah, 5 and 3 are very similar. Yep, I'd argue there's very little difference between 5 and 3. So if you could do question 3, you should be able to do question 5. For question 6, it's a very interesting pattern. So one dark triangle becomes 3 shaded triangles, or 3. What's the wording they use there? Yeah, so shaded. So one shaded triangle becomes 3 shaded triangles. And if you continue that pattern, you're basically tripling the amount of shaded triangles you have. So you can use basically the formula for the general term of a geometric sequence, because it's the number of shaded triangles is a geometric sequence. Okay, and there's a natural number there. Beautiful. Okay. All right, for question 7, you're given the doubling period. So you're basically finding the population after 12 doubling periods, because 7 days is 12 doubling periods. Okay, so what's the 12th term? 200, 400, 800, the common ratio is 2 because you're doubling. So find the 12th term. So after 7 days, there are 409,600 bacteria. I'm just looking through the sheet and making sure I have natural numbers. So I'm going to go back to question 1. When you write the explicit formula, you should really say that n is a natural number. It's very easy to forget, but it's very important. So I'm just going to go fill that in. Now, if you're just building equation solving, I guess you could write it, but it's not as important as someone just writing the explicit formula. Okay, so that's the solution for geometric sequences.